Hi, I hope you're doing well. Welcome back to this lecture series, which is Instrumentation and Measurement Systems. So most of the universities find this course place this course in second year diploma or in second year bachelor. So however, this is one of the basic level courses, but there is an engineering stream which is only focusing on instrumentation, electronics and instrumentation engineering, right? So there is much that we can say in this particular course. So let me now start this course by giving the definition of this particular course title, right? So what is this course title? It's about instrumentation. So what is instrument? Instrument is nothing but tool, am I right? So it's about tool. So what is a tool? Tool is a device which is used or designed for a specific work, for a specific purpose. So a screwdriver is a tool designed to tighten the screws and loosen the screws, right? A drilling machine, it's a tool which can be used to put up the holes into in wooden blocks or even in concrete structures. So however, this drilling machine can't be replaced by this screwdriver. A screwdriver can't be replaced by a drilling machine. So however, I wanted to give an idea here that instrument is a device which is designed for a specific purpose. We can't be interchanging that purpose, right? So however, so those instruments we're going to see here. Now the question comes, teacher, are we going to study about screwdriver in this course? No. We're not going to study about this kind of instruments. Rather, we're going to study about those instruments which are useful in the process of measurement. What did I say? So we're going to study about the instruments which are useful in designing a measurement system. This is how we can correlate this instrumentation and measurement systems. Now the question comes, what is measurement? The other word is gauge, right? It's about gauging. So what is this gauging or measurement system? So the measurement system is something which will allow us to know the quantity of a certain substance. Am I right? Let's say there is one. Let's say there is a lot that is present in this universe, and everything has got a specific quantity. How much is it present? If you want to know that, you got to have a measurement system. Am I right? So, in fact, we do use measurement systems in our daily life, and without a measurement system, I would make a statement that you and I can't lead our life even a single hour. We can't run our day. We can't run our time. It's very impossible. In fact, the time that you see on your wristwatch is also on your wrist. It's a wristwatch, right? So it's also a measurement system. However, instrumentation and measurement system is a part of human beings' life. Is a part of our daily life, right? Our daily needs are based on them. So however, let me go ahead and see what am I going to give in this particular lecture, right? So let me first take the first lecture. The contents are, so what is a measurement system, and what is the analogous understanding of a measurement system? This is unique. You would find it interesting, right? And then what is the technical definition that the books have to give, right? So, and then the understanding of a measurement system which measures the temperature, a liquid thermometer, how it works, and then comes the block diagram of the measurement system. How exactly you can define a block diagram based upon the books, authors which are who are really famous. So based upon their writings in their books, how we can define a measurement system, and then based on that, how can we finalize or figure out the essential elements or functional elements in a measurement system. Let us go ahead. It will take about 15 to 20 minutes to finish up this lecture. So let me now take up what is measurement. So a famous book, one of the famous book in Indian context is Electrical Measurement Systems by A.K. Sahani. He says one very good statement. I get attracted towards this statement. He says that whatever exists in this universe exists in some amount. It's true. And if you want to know about that, you got to run a measurement system. So let's say you want to know about how much water is present. You have to compare the whole earth and its percentage. And then we say 3/4 of earth is covered with water. And yes, there is a measurement that we can run in measuring or to measure air, right? And then fire for having space. So all these are present in our universe, right? On our earth, in fact. So whatever exists in this universe is existing in certain purpose, in certain amount. So in order to know that, yes, we got to have a kind of measurement system. So measurement is a process of knowing something unknown. I would say this in my classroom. Measurement is a process or a phenomenon that helps us to know something unknown in specific numerical number. So this is how we define about measurement system. Let me now go ahead towards some of the interesting or important weather parameters. Like there is temperature that we can measure. Yes, we got to measure that. So in my place where I'm staying right now in Muscat, right, the temperatures are about 40 or 45. Sometimes it's even more than that. So humidity is also too high here. So we got to measure wind speed. We use some kind of anemometers to measure that, and pressure sensors are also available to measure humidity and temperature. We got sensors called DHT11 or GHT22. So however, we got to measure these measurements, these particular quantities, and we have to design a measurement system to measure these quantities. Are you with me? Yes, let's go ahead. So most common physical parameters that we intend to measure is about mass in kgs and volume, distance, displacement, and time. So these are all the different parameters that comes in physical under physical variables, right? Let me go ahead towards determining the amount is measurement. So what are the different examples that we can take? Yeah, what not? We get everything here. If you want to measure about there is oil flow in the pipelines of PDO, Petroleum Development Organization. So if you go there, you find only about maximum of the PDOs will have the pipeline structures, and we got to design a measurement system in order to measure the pressure that is being maintained in the pipeline, as well the temperature of the oil or the petrol or whatever that is going in through the pipeline, and also we got to measure the flow rate using a rotometer sensor. So however, we got to have a measurement system to measure the flow rate, or the pressure, temperature, and whatever that are essentially to be measured in a PDO for their operations. Then see, as an electrical engineer, I myself, we would use some measurement systems in measuring the current, voltage, power, power factor measurement, energy measurement. There is one sensor which is very much used these days, Peugeot EM0040. This sensor helps us in measuring voltage, power, current, energy, and also power factor. So it's named as multifunctional energy meter. So yes, we do that. And measurement of earth plates, movement of earth plates. So how do they move exactly? So during the times of earthquakes, how exactly the movement of earth plates can be monitored. So we can design, we can have a measurement system to do that, and we have a device called Richter scale to do the same. And not only that, there are many mechanical, electrical, weather, and biological parameters which we got to measure in order to run the systems properly, accurately. So measurement is a process which is inevitable. We can't run a single day, as I said before, without measurement. So let us go and see what exactly is a measurement system. What exactly is measurement system is, and what it should be actually. So this is a very interesting one, and I would say this is one of the important slides, right? See, what is this biological measurement system that we have in us? So if you ask me, I have a different way of defining a measurement system. I would say that measurement system is within us. It's biologically present within us, and we are using it in every moment of our life. See I'm just giving it an example where you find two different people, right? Two different small kids. Yeah, let's say this is an elder, right? And this is an you know, younger one, elder one and younger one, or you can name it as whatever that you can. So what is happening? This guy is having a big chocolate in his hand, and this guy has got a small one in his hand. See, what is this guy is doing there? This guy, this little one, younger one, definitely you can see a facial expression of this guy, right? What is he doing? He is a bit sad. Am I right? He's a bit sad. In fact, after some time, it seems that he would cry out. So, what is making him cry? You know, what's happening in his mind at the moment? If you see, this guy is looking at this guy's biscuit, right? And he is looking at his biscuit, and the other guys who is sitting beside, maybe this is his biscuit and this is the other guy's biscuit. So what is that he's doing? He's comparing the sizes of these two biscuits, chocolates, whatever, and then according to the comparison, right, he understood, or based on the comparison, he understood that his brother or this elder, right, got a bigger one, a bigger chocolate, bigger biscuit. So what's happening, my dear? And that is making him cry. Of course, then it would be a very difficult task for the parents to handle the kids. However, what am I trying to say is that this guy's brain is automatically, or has got the ability to perform measurement. How is he doing? He's doing measurement by the process of comparison. Are you with me? He's comparing. So if you wanted to run, how the measurement is being done here in this particular example, this guy, a little one, how is he figuring out that his biscuit is smaller than his brother's? So how is he doing that? He's comparing his biscuit with his brother's, and then with a comparison he understood that his biscuit is smaller. So comparison is the biggest tool for any measurement system. So I hope it is making sense, right? So in biological system that we have, we do measure many things. So however, the baseline principle that helps us to measure is comparison. Let us now see the definition that the books have to give to us. Measurement of a quantity is essentially an act or result of comparison between a quantity whose magnitude is unknown with a similar quantity, standard quantity. So this is the definition that we got from a book, right? So what I'm trying to say here is that this little guy is already doing it. What is he doing? He has his chocolate and he's comparing this chocolate with his brother's. So what is he doing? He's comparing the one which he's trying to measure with a standard one. His brother's chocolate is a standard one for him. So however, what I say here is that this measurement of any quantity essentially based on comparison. Comparison of what? Comparison of the quantity that you want to measure and the similar quantity which is a standard to continue or to run a measurement system. This is a block diagram that we can have. See here. So there is an input. So any measurement system has got an input and has got an input and output. Right? But input is a unknown quantity, but output is a known quantity. Okay, and technically the measurement, the input of a measurement system which is unknown is called measuring. You may find a question in the examinations. What is measuring? It's the input of a measurement system. And what is the output of a measurement system? It's called measured. It's a technical definition, my dear. So how exactly is this happening? It's actually a process of comparison. So how is it being compared? What values are being compared here? The one which is unknown is compared with the standard known quantity, and finally you're able to figure out the value that is to be measured. Is this? I hope it is making sense. Right? So let us now see something more in measurement systems, some important aspects, right? So let's see some different biological systems and what we got to understand here. Yeah, these are all the different biological systems that we run every day, my dear. So we as humans possess these measurement systems within us. We got it then. We got in us, right? So let's say this lady is eating some food. Right. So what must be going on in his, in her mind while she eats? So let's say you go to a restaurant or you go to a new biryani house or a good food place, right? Food restaurant, and then you are going there for the first time. All right, and you are tasting the food there for the first time. So what will happen the moment when you take the so you order the food and the food has come and you take the spoon of the spoon, 1 spoon of that particular food, and then you put that on your tongue, inside your mouth, on the tongue, right? So then the tongue will take the information from the food and send it to the brains. Are you with me? So what is happening here? The tongue is taking the food information to where? To the brain. Number two is brain. Right? So what does the brain do? What does the brain do here? Brain has set of tastes. Let's say if you're eating a burger there, right? If you're eating a burger, first time. So you have tasted the best burgers in the world. Maybe your brain has the memory of all these different tastes of burgers, and then it ranges from number 1 to number 10, let's say. And obviously number 1 will be the one which is made by your mom. Am I right? It'll be. So if it is for me, I would say my mom's food made from her hand by herself is the best food, is the best taste that my brain ever can remember. Right? So now whenever a new taste goes in, then the tongue will give the information to the brain. Brain will try to compare. Again, the comparison has come. Do you understand, my dear? Comparison is a very important process that exists in a measurement system. Okay, so the brain will take that new taste, and what it does, it compares that taste with the existing set of tastes. Then what does it do? Then it keeps that, or it gives a rating to this new taste, and then it would say it is number 2, or it is number 11, worst taste that you have ever tasted. So this is how your brain is going to give you certain idea about how the taste is. So what is this? It's about taste measurement system, or so you can define like that, no issues. And finally, what do you say if it is very good? See how this lady is eating. She is eating the balls, maybe she liked the food and she's continuously eating. It's an animal. Okay, so it looks like that. But however, if the food is not good, what do you do? You just shout and then say it's not good at all, so sorry. Or you may give a feedback through by clicking something. So the third thing that you need is presentation. So in order to express the measured value, in order to present the measurement that is being done, you need the third element. Are you with me, my dear? So how many elements are needed here? How many important stages of measurement are seen here? Number 1, taking the information. And number 2, processing the information. And then expressing based on the decision taken by the brain. The 3 stages, remember that. Same is the case here. You can now analogously understand. Same is the case here in measuring the temperature. So your skin is a big organ, the biggest organ on your body, right? So you can measure the temperature with the help of this wonderful sensor given by the God Almighty. And also, the smell sensing ability is given to your nose. Helps us to know which is good and which is bad, and yes, which sound is so pretty to listen. So that's how you can have different biological systems. We got 5 different sensors, and all these 5 different sensors will help us to measure and lead to measure certain important things in our life and help us to lead a life with all comforts. Do you understand? So let us now go ahead and see a kind of measurement system which is present in our physical world. Okay, so what is this? It's a liquid thermometer. It's a thermometer. It's a thermometer, right? So what is it having actually? See, I'm going to draw it for you. This side, let's say there is a glass tube, and then yeah, it has its body, right? Am I right, my dear? And inside of this glass tube, you got the liquid. What is this liquid that is present inside of it? Yes, this is the mercury that is present. That's why it's called with the name mercury thermometer. And to the inner side of it, there is an inner tube with kink placed in here that will help us to manage the mercury within, right? Yeah. So and then on the top of the glass, so you got the, what is this? You got the scale, calibrated scale. This is how you got a liquid measurement system or liquid thermometer, which is a, what is this called? It is a temperature measurement system. Are you with me? Yeah, temperature measurement system. Now let us see, how does it work? How does it work? How exactly it measures the temperature? Say, when you go to doctor, what does the doctor do? Doctor will take that thermometer, he would do something, he would shake it down and make sure that the mercury comes down to this glass tube, This is the glass tube, right? Right? He shakes it down, and then he makes sure that the liquid comes down and then cleans it up and places under the tongue, where we find the exact temperature of the body. And then like this, as I depicted in this picture, right? So, and he waits for 60 seconds of time, am I right? And after 60 seconds, he would see, so what is he doing? What happened in that 60 seconds? This mercury thermometer, this mercury which is present in this glass tube, when it is exposed to higher temperatures under the tongue, there is a temperature, the total body temperature, the actual temperature of the body is present there. So this glass tube will be, will be exposed to that part of the body, and then it takes the heat. I mean, the glass will get heated up, and thereby the liquid that is present inside, that is mercury, will get heated up. And we all know from our basic chemistry that whenever mercury is exposed to higher temperatures, it has a property to expand. If it is exposed to lower temperatures, it has a property to contract. Are you with me? Yes. So because it is now exposed to higher temperature, now this mercury that is present inside would now expand through the inner glass tube. Maybe it is expanded until this point. So it would take 60 seconds, for the complete, expansion. So after 60 seconds, meaning after the liquid is completely, or mercury is fully expanded, the doctor takes it out, and then what he does, he compares this with the calibrated scale, that is the level of the mercury with the calibrated scale that is already present down there. So I'm going to take another color. So this may be 5 degrees, 10 degrees, 15 degrees, 20 degrees, 25 degrees, 30 degrees, and the moment when he compares it, it is 30 degrees, and he would say there is nothing to worry. It's not about fever anymore. There is no temperature, and he would not suggest any medication if it is so, right? However, this is the fundamental principle of a temperature measurement system, right? That we usually use in our daily life. We use it, right? In our houses, we got it. Right. Now what I'm trying to say here is, what are the important elements that are present here? that are present here? Can you tell me? Can you guess? Can you try to figure out? Yeah. So I'll try to explain you now. See, glass tube which is now exposed to heat, what is it acting as? It is a first element that is being in work, that is working there, that is helping the temperature to be measured. And the second thing, the mercury and the inner tube, this is the number 2 element that is present in there, which is reacting to the temperature and processing the temperature input. How it is processing? It is being expanded, meaning the signal that it is receiving, the input temperature signal, is being processed. Is being processed in terms of the liquid expansion, mercury expansion. So once the expansion is done, there is one more thing that is present there, that is the calibrated scale. So this is number 3. Are you understanding what I'm trying to give you? I'm trying to tell you that there are 3 different important elements, essential elements, functional elements in a measurement system which will be required to make a measurement system, which are important in measurement system, which are, without them, you can't design a measurement system. Are you with me? Let's say the glass tube is broken. Can you have a measurement system? You can't. Let's say the mercury isn't present there. You can't have a measurement system without this, rather. Right? And then if the scale is now faded away, though the glass tube is sensing the temperature, mercury is being expanded, number 1, number 2 are present, they are functioning fine. If the scale is faded there, if it is an old thermometer, you can't know what is the temperature, because you can't compare and you can't figure out the actual numerical value of the temperature. You must need the scale present on the outer part of the thermometer. So you need 3 different functional elements, my dear. Are you with me? Yes. So if you wanted to now make out a list of essential elements, now I would say there are 3 functional elements, essential elements that are present in a measurement, that must be present in a measurement system. The first one is the one which takes the information from the input variable that I call as sensor. And the second one is about the element which processes the input. So this I call as signal conditioning unit. Excuse me, my handwriting is not so good, right? And then the last one is data presentation system. Yeah, are you with me? If you open any book, in the first front page you find this. It isn't just presented like this. So there is a big story to tell. That's what the story that I have told until now. Are you understanding me? So I'll just go back. Yeah. So this is how a biological measurement system has 3 different elements to run a measurement system within us. And even if in a liquid thermometer or mercury thermometer, we got this measurement system working using 3 essential elements, right? And now, if you see, we can, based upon that 2 examples of those 2 slides, we can figure out that there are 3 functional elements. One we can call or define it as sensor. The other is signal conditioning unit. The third one is data presentation system. Now, this is the sensor, number 1, am I right? And this is the signal conditioning unit, and this is the data presentation system. In a biological system, tongue is a sensor, brain is signal conditioning unit, and you present that feedback, right? Whether taste is good or not, that is presenting the data presentation system. So however, even we can witness that 3 different systems functioning continuously within us in order to measure that is present, that is to be measured, right? So that is the end of the first lecture. So I would also give a block diagram which will help us in which would help us in placing these 3 functional elements. So how are they connected? This is the sensor. This is the first whatever element which responds to the input. This is the input. So what is this? It's a block diagram of a measurement system. Okay, so what is the first element? Sensor, and the sensor's output is connected to what? To a signal conditioning unit, and then the last one is the data presentation system. So finally you get an output. So this is unknown as it is depicted before, and now it's known. You measured it. I hope this is this is clear to you. This is the end of the first lecture. Let's meet for the second lecture after this. Thank you.